Professor Salamir, and now over to you.
Doctor, just 1 minute, please. Has this started on the YouTube?
No, ma'am, not yet.
Please start on the YouTube, please, Mr. Sarabjit ji. Only then ma'am will start the program. Sarabjit ji, please start the YouTube link.
Ma'am, done, ma'am.
Done? Okay. Now you can start, ma'am. Over to you, Dr. Munir. Please start. No?
ما تيجي يا عاطف عشان طالبين الفيديو يا عاطف.
Just a minute. Just a minute. Yes, Deepti.
Ma'am, give me 1 minute.
1 minute. Okay. Just please wait for 1 minute.
انت توصل كل حاجه ما هتوه. والله مبدله بسلايدز ما كان والله حسبي الله ونعم الوكيل.
Sarabjit sir? Sarabjit sir?
Yes, ma'am.
Sir, एक बार फोन उठा लेंगे?
طبعا مش هنعرف نغير خلاص ما حاجه.
Ma'am, we can start. Ma'am, we can start.
Dr. Munir,
I
we can
can
start.
start?
Yeah, yes, ma'am. Thank you. Yes.
Okay, thank you. Ladies and gentlemen, good afternoon. I would like to thank Dr. Professor Agrawal and Professor Sharma for planning this international webinar and inviting me to present today an interesting topic in food processing. And I thank also all the organization committee and the technical support staff. I would like to thank also Professor Nema for his recommendation. So today I am going to present and discuss the extrusion technology and its different applications in improving the quality of food products. Okay. So we will discuss about the main parts of extruder and the different processing zone within the extruder. Also the different classifications of extruder and extrusion process, the major factors affecting the quality attributes of the final products, and also some applications of extrusion technology in food production and the different types of extruded products and their manufacturing process. And finally, we will discuss about the recent trends in extrusion technology, which is vacuum extrusion and extrusion emulsification, which is applied in dairy powder. So the extrusion process is defined as a process where a material is pushed or forced out by compression through a die with a design specific to the food product, shaping and expanding the mix. The pushing force is applied using a screw, so the machine which forces the mix is called as an extruder, while the mix is known as an extrudate. Now we will see how the term of extrusion is defined from the industrial point of view. From industrial point of view, extrusion means giving certain shapes and forms to the food materials without affecting or changing their properties. For example, extrusion in pasta press and pellets. These products could be formed and shaped with different shapes without changing their properties. Coming back to the extruder consists of a large rotating screw tightly fitted within the barrel, attached with a driver motor, and at the end of which is the die. A typical extruder consists of variable screw feeder with holding pin, preconditioner, extruder barrel assembly, die head assembly. In extrusion process, the raw materials are firstly ground to the corrected particle size, usually coarse flour. Then the dry mix is passed through a preconditioner where other ingredients are added depending on the target products. These may be liquid sugars, fat, dyes, meat, or water. So water can act as a plasticizer, facilitating the reaching of the glass transition temperature, at which the state of the mix changes from the glassy to rubbery state before steam injection and before starting cooking process. Cooking process takes place within the extruder when the product produces its own friction and heat due to the pressure generated by friction. And the other additional heat may be provided by a steam injected barrel or by a steam heated screw or other heating sources such as electrical heaters present around the barrel. The rotation of a screw allows mixing, homogenization, and kneading the mix and conveying it to the different processing zones within the extruder. So as a result of some physical and chemical changes, we obtain a viscoelastic melt which is compressed and forced towards the die through which it then exits. So the expansion of melt takes place in the die swell where the pressure is dropped towards the atmospheric pressure, flashing off the steam and expanding the melt. The extruder then cut to desired lengths with blades at the output of extrude. The product is then cooled and dried, becoming rigid while maintaining porosity and expansion. So extrusion is a process in which heat transfer, mass transfer, pressure changes, and shear are combined together and applied to the food material or mix, producing some effects or some unit operations such as conveying, mixing, kneading, cooking, melting, swelling, conching, and also forming and texturing, and finally cooling and drying. The screw which present, we come to the screw. The screw which is present inside the barrel may be one piece or multi-pieces with different fragments, and each fragment has a specific function, such as transport or conveying the raw material, compress the mix, or knead and shear the melt. Here, I show you some photos of barrel screw types and the different types of the die. Barrel may be smooth or grooved. Grooved barrel acts as lubricant to reduce or prevent the material thickness on the screw, so facilitating its flow during the different processing zones. Here we can see the different fragments of screw, and this is one piece of screw. And this is the different types of die holes, which can use to form many kinds of products. So as we see from this photo, dies have different holes. For example, round holes to produce rods, square holes for bars, and the slots for produce sheets. So different kinds of shapes, holes are present in the dies and produce different complex shapes of the product. So the function of the die is to shape the melt when exits the extrusion, and also contributes to the physical properties by controlling the molecular orientation in the product. Now, let's discuss about different classifications of extruder and extrusion process. We have two types of the classifications. The first one is according to the configuration of the extruder, and the second one is based on the operation mode. Coming to the first classification, which is according to the constructions of extruder, there are two types of extruder. The first one is single screw, and the second type is twin screw. Single screw extruder contains only one smooth screw present inside the barrel and used for processing low moisture food materials. Single screw machines may be low or moderate or high shear machines depending on the friction generating and the pressure exerted within the machine. Coming to the other type of machine, which is twin screw extruder. Twin screw machines contain two screws inside the barrel, and this type of machine is used for high moisture sticky materials. Screw rotation in the twin screw machines may be co-rotation or counter-rotation. And co-rotating screw both screw rotate in the same direction, creating controlled shearing. While in counter-rotating screws rotate in an opposite direction, creating high shearing and high pressure zones. Here, I show you some different application of single and twin screw machines. For example, single screw machines is used for making texturized vegetable protein, direct expanded snack, while twin screw machines could be used to produce pre-cooked pasta and the other different kinds of pasta, and also to produce confectionery products as seen in this slide. Now let's go into the second classification according to the operation mode. Coming to the types of extrusion process, there are two types of extrusion process. The first one is a cold extrusion. This technique mixes and shapes only food materials such as biscuit dough and pasta without cooking them, because the temperature applied in this technique is less than 100 degrees. So there is no cooking in this technique. High moisture food materials such as meat products and pasta and biscuit dough are simply formed and shaped into different shapes like roots, tubes, and strips. And we can change the shapes using different kinds of dies with different dimensions. In this technique, a little of friction is generated. So the machine is often equipped with cooling system to reduce the heating generated from friction. And also to avoid the expansion of food material, along with the extruder configuration, which contain deep flight screw. So cold extrusion is low shear, low pressure technique with only mechanical effect applied to the food material. Then we have the second type of extrusion, that is hot extrusion or extrusion cooking, with which a wide range of products could be produced, such as crispy snacks, foods, sugar confectionery products, and soybean-based weaning foods. During the extrusion cooking, the food material is cooked by different heat sources, such as heat generated from friction or by direct injection of steam, and also maybe by supplementary heaters which are present in the barrel. The temperature of cooking applied in this technique is more than 100 degrees. In this process, high pressure and high shearing are created. So the extrusion cooking could be defined as thermomechanical technique as a result of combined effects of heating and shearing, allowing the swelling or expansion of food material. Now let's go into the details of extrusion cooking, as it is the most technique used in the production. Excuse me. Now let's go into the details of extrusion cooking, as it is the most technique used in the production of large number of food products. The principle of extrusion cooking is based on combining the use of moisture and heat during the preconditioning step and of different ingredients, followed by applying mechanical forces or effects of pressure and friction to the food material. And finally, texturizing, drying, and cooling operations. So the object or the aim of extrusion cooking is mainly cooking the raw material or food material, followed by swelling of the food. Now, let's see what about the different processing zones within the extruder. We have 3 different zones within the extruder with different profile of pressure and temperature. The first zone is the feeding zone. In this zone, the preconditioned raw materials are introduced in the barrel and conveyed along the barrel by rotating screw. So no compression or modification of mass can be observed in this zone, or a slight compression of material, we can say that. The second zone is a transition or compression zone. This zone is known as kneading zone, where mixing and homogenization take place. The compression of food material occurs as a result of increasing of pressure and temperature. The flow channels of extruders achieve high degree of filling as their volume decreases and the screw diameter increase. So shearing starts to play the predominant role because of barrel filling effects, and an increase in temperature and pressure can be observed in this zone. The third zone is metering zone. So changes of the material can be observed as a result of cooking, melting, and some chemical reactions such as protein denaturation, texturization, and starch gelatinization, forming viscoelastic melt which is forced out the dye. The temperature and pressure increase very rapidly, and the shear rate is higher in this zone as compared with the previous zones, owing to the screw configuration, which is drapped screw as shown here with shallow fly. This figure shows the evolution of pressure during the 3 zones, which is increased gradually and reaching the maximum in the metering zone. Now I'll discuss about the raw material, excuse me, because Now I'll discuss about the raw materials used to make different extruded products. There are different types of raw materials used to produce different kinds of food products by extrusion cooking, and they have different function. For example, structure forming, which are rich in starch, like cereals such as wheat, flour, maize, rice, cassava, and some tubers such as potato. These materials are the main ingredients used for extrusion cooking. The second type is fillers, such as protein, which is added to the main ingredients with the object of improving the dough flexibility, controlling the texture and the shape of extruded, reducing the size of air bubbles during the expansion, thereby affecting the shape and the texture of final product. We have another type of raw material called plasticizer. The plasticizer in the extrusion cooking are water, fat, oil, and emulsifier. They affect the flow of material inside the barrel. For example, fat and oil acts as lubricant, facilitating mass flow and reducing the thickness of material on screw. And also can reduce the degradation of starch, decreasing the barrel temperature and friction. Improve the melt rheology and also improve the quality and the nutritive value of the end product. And it can also reduce the residence time in the extruder. For example, adding water allows reaching the glass transition temperature rapidly, which in turn enables the different chemical changes such as starch gelatinization and protein denaturation to be occurred in a short time. We also have raising agents such as baking powder. It is used to provide a perfect aeration of the mass and help obtaining the typical crispy and porous structure of extruding. And we have also flavoring material, which could be also added, such as sugar, salt, spices, and other flavors, just to improve and enhance the taste and the flavor of final product. We have also some coloring materials can be added as well to impart different color to the end product. It's okay? Hello?
Yes, ma'am, it's fine.
Now let's discuss about some molecular transformation which happen during the extrusion process. We have many types of transformations which take place during the extrusion cooking. The first one is starch gelatinization. Starch gelatinization is the main effect of extrusion cooking and known as basting. Starch represents about 60 to 70% of raw materials, and we have starch from cereal or legume flours like wheat, rice, maize, barley, and sometimes from tuber flours also, such as potato, cassava, which are used for producing breakfast cereals, snack foods, and pasta and biscuit dough. Starch granules in the presence of water and heat and grow some changes like gelatinization, while severe extrusion conditions cause starch damage and degradation. So starch gelatinization allow creating a visco elastic melt which expanded as the dye with a stable porous structure after steam flashing off as a result of instant dropping of pressure towards the atmospheric pressure. The second type of transformation is protein denaturation and texturization. The extrusion cooking can also induce both protein denaturation and texturization. Native proteins are denatured during extrusion process owing to that the forces which stabilize the protein structure are weakened by combined effect of increased temperature and shearing within the extruder. The protein denaturation induces protein-protein interactions forming cross-linking which stabilize the new texture. While texturization means restructuring the melt on fibrous form where some orientations and rearrangement of protein chains which align themselves with the flow of material towards the die forming meat-like structure. Now let's discuss how the melt expands during the extrusion cooking. We have two types of state. We have a glass state and we have rubber state. And this is the glass transition border. So the raw materials which used for extrusion cooking usually in a dry matter in form of powder. So these powders must or should be rehydrated before starting extrusion. So the increasing of water content of material change state from glassy state to rubbery state. As we see here, that increasing the water content, it changes the glassy state to rubbery state. After that, after rehydration and changing the state of raw material from glassy state to rubbery state, steam is injected and the extrusion process starts. Under the effect of heating and shearing, some chemical modifications can be happen, such as starch gelatinization, denaturation of protein, and also some orientation or texturization. And also we have melting of fat. As a result, we obtain a fluid melt with viscoelastic behavior, which is forced towards the die. As the die, the pressure is dropped towards the atmospheric pressure, inducing flashing of steam and expanding the melt. But the expanding melt is still in rubbery state, as shown in this figure. So a step of drying or cooling is needed to reduce the temperature, the water content, and enable the product or expanded milk to cross the glass transition border to be in the glassy state, solidifying the new crispy porous structure obtained during extrusion process. So the philosophy of expansion is to have melt with viscoelastic behavior to get a great rate of expanded gas within the material, and after that cross the glass transition border to get the glassy state, reflecting the typical crispness and crunchiness of expanded products. Now, I am going to discuss about the main factors affecting the quality of extruded products. We have three categories of interrelated factors. The first one is the factors related to screw configuration, such as size, number, pitch, and diameter of the flight. And the second category is related to the design of the die, which affect the product shape and the size, such as die pressure and the dP across the die and heat generated by friction. The third type of factors is the process parameters or operation parameters, such as screw speed and temperature, and also composition of the raw material and feeding rate. All these factors are interrelated, affecting the shear rate and friction, and also the generated heat, which in turn affect the melt rheology, which plays a predominant role in the determination of quality of extruded products in terms of expansion ratio, bulk density, water absorption index, water solubility index, and the cooking degree in case of pasta. So the selection of the correct type of extruder and the operating conditions have to be carefully considered. Moisture is found to be the most factor affecting the quality of extruded products, where the expansion ratio and the crispness increase with decreasing the moisture content of raw material, along with the high temperature and the speed of screw. Because moisture affects the mix viscosity, owing to the water acts as plasticizer, decreasing the viscosity and product temperature, and then depresses the glass transition temperature. As a result, the product can't be expanded and has a dense structure with rubbery state. And this increases the bulk density and the hardness of the final extruded product. Water absorption index is an indicator of starch gelatinization degree, while water solubility index is an indicator of degradation and conversion degree of starch and fiber. Moisture content is the main factor affecting the starch gelatinization, where high moisture content decreases the mix viscosity, so we need more mixing and more homogenization and uniform heating to enhance starch gelatinization. While in case of low moisture content, the friction between dough and screw and dough and barrel increases with the decrease in the moisture content, causing starch degradation or starch damage. As a result, water solubility index increases and water absorption decreases. But a contradicting trend is observed with increasing and decreasing the screw speed and temperature. Now I'll discuss about the effect of extrusion cooking on the nutritive value of extruded products. Extrusion process has benefit effects and sometimes harmful effects. Benefit effects include improving the digestibility of starch and protein, which is important in weaning foods as a result of starch gelatinization and protein denaturation. And the improved protein digestibility may also be related to the destruction of some anti-nutritional compounds, and also can increase the bioavailability of bioactive compounds such as phenols, resulting from breaking down the cell walls and release of the bound phenols. And also can improve the absorption of some minerals such as iron through destroying tannins which bound with. On the other hand, it has some harmful effects such as decrease the protein quality because of lysine loss in the Maillard reaction. And the lipids and vitamins can be also lost during the extrusion because of oil forcing out from the mix or the formation of lipid amylase complex. And the thermal degradation of vitamins such as vitamin C could also contribute to the loss of vitamin during the extrusion process. The extrusion cooked products are microbiologically safe because of combined effect of shearing and heating, which induces a significant sterilization even at low temperature. And also the drying fluid, the extrusion decreases the water content and the water activity. But the mechanism of spore destruction is not well understood till now, but it may due to the shearing effect. After discussing the details of extrusion cooking and the quality of extruded products, now I am going to discuss the different extruded products and their processing methods. We have three types of extruded products, including cereal-based products, such as expanded snack foods, ready-to-eat and puff cereals, breakfast cereals, pasta products, crisp bread and crouton, weaning foods. The second type is protein-based products such as texturized vegetable protein, TPP, hot dogs, surimi. And the third type is sugar-based products such as chewing gum, liquorized candy, toffee, and fruits gum. Pasta is produced by cold extrusion and known as pasta press. So extruder is often equipped with cooling system. A pasta extruder is used to make many different types of pasta using dough made from drum wheat, flour, usually semolina, and eggs, which is an option. After forming and shaping the dough, a step of drying is necessary to reduce water content and stabilizing the final product. But it is worth to mention here that air must be removed from the mix before extruding to avoid air bubbles in the final products, which in turn affects its mechanical strength and its appearance. Colored pasta can also made by adding tomato puree and Spanish paste. And we can also add some flavors to the mix and get different kinds of pasta. Pre-cooked pasta is produced by similar operating steps, but cold extrusion is replaced by extrusion cooking or hot extrusion. And the washing step in hot water is performed or carried out before drying, just to remove starch which collected on the surface. The pre-cooked pasta is rapidly rehydrated even in cold water, as compared to the pasta made by cold extrusion. And this because of the starch gelatinization degree, which is higher in the pre-cooked pasta than that of the other pasta kinds, which is around 80 to 90% in pre-cooked pasta, while in the other kinds of pasta is about 50%. Snack foods. There are two types of snacks. The first one is indirect expanded snacks, and the second one is the direct expanded snacks. Coming to indirect expanded snacks, this type of snacks is known as half products and do not expanded when exit the die, such as pellets, fabricated chips, and tortilla. So additional processing after extrusion are required, such as frying or hot air buffing or flaking. So extrusion, an indirect expanded snacks produced by two-step processing. The first step is extrusion cooking without expansion, where the pressure is released before exits the die, followed by a drying step to reduce the water content to 12%, which is sufficient to plasticize and expand the pellets when exposed to high temperature, where the residual moisture is in these products turns into steam, which rapidly expands them and produces snacks food. Cornflakes is an example of indirect expanded snacks. Cornflakes are produced by mixing corn flour with other ingredients, such as malt as sweetener, and then extruded without swelling in form of large granules, and finally pre-dried to reduce the water content. The pre-dried product then passes into a flaking or toasting machine to produce ready-to-eat cereals. Sugars, flavors, and vitamins can be added after extrusion. Coming back to direct expanded snacks, this type of snacks is expanded when exits the die, such as corn kernels, rice puffs, and potato sticks, which is produced with high shear cooking extruder at high temperature, higher than 100 degrees. So no further processes are needed to expand the product, only just a drying step to reduce the moisture content. An example, excuse me, sorry. An example of direct expanded granule is corn kernels. Preconditioning corn grits with about 15% as water content are introduced in the barrel and extrusion cooked at temperature of 160 to 180 degrees. The extruded exits the die with moisture content of 8%. And then it dried or baked or fried to reduce the water contents to be 2 to 3% as final water content. Flavoring can be added after the products during and then cooled at the room temperature. So the operations before extrusion are known as upstream process, while the operations after extrusion are known as downstream process. Bread-like structure can be also produced by extrusion cooking of cereal dough. The process of manufacturing is similar to that of direct expanded snacks. Baking and toasting are carried out to produce crunchy crusts, but the organoleptic properties are not similar to that of a traditional baked bread because yeast is not added in this technique. Now let's see further extruded products such as texturized vegetable protein, TVP. There are two types of TVP. The first one is meat extenders, and the second type is meat analogs. Meat extenders are high expanded meat products with porous structure and without fibrous texture, while meat analogs are not expanded product with dense and fibrous texture resulting from layer fiber conformation. TVP can be produced from soy protein concentrate or from soy flour. These raw materials are preconditioned with steam to increase the moisture content to 20% and then extrusion cooked. During the extrusion cooking, some orientations and rearrangements of protein chains with meat-like structure under the effect of unidirectional shear, and then align themselves to impart the desired fibrous texture and then dried. Other protein flours can be also used, such as sunflower, cotton seeds, and peanuts. Now, let's now see what about the confectionery products. Liquorized candy and chewing gum can also be produced by extrusion cooking from mixing and heating of sugar, corn syrup, flour, starch, fruit concentrate, and the other ingredients, which are multi-phase food materials. And co-extrusion can also be used to produce multicolored products such as fruit twist and multi-phase fillet products. Extrusion conching is a particular word applied only to chocolate, which means mixing, aeration, evaporation, homogenization, and size reduction, where heat generated by fraction liquefies the chocolate mass and evaporates water and other volatiles. And the shearing action reduces the size of the solid particle and then coated with coca fat. After discussing the different types of extruded products and their manufacturing process, we are coming to recent trends in extrusion technology. The first one is vacuum assisted extrusion. The idea beyond this technique is to produce expanded products at low temperature with high nutritive quality. As shown in this figure, a vacuum system is connected with the die, with extrusion at the die. So as shown from these figures, it is found that expansion ratio and total phenolic compounds increased with increasing the vacuum level. The higher the vacuum level, the higher each of the expansion ratio and the total phenolic compounds. Whereas bulk density and water solubility index showed a contradicted trend with increasing the vacuum level. So this technique allows producing expanding product at relatively low temperature with high nutritive quality. The second trend is extrusion purification. This technique based on foam formation into high viscous concentrate. The foam formed by injection of gas such as CO2. The viscous concentrate extruded at low temperature, about 20 degrees, and at low pressure, about 6 to 8 bar. Then the gas injected and the aerated concentrate then spray dried at different temperature. This technique allows obtaining powder. Obtaining powder with porous structure as seen here, decreasing the outlet temperature. The traditional spray drying has dense compact texture without agglomerated particle, but the extrusion purified powders have an open porous structure with some agglomerated particle. So a step of agglomeration is not needed here in this technique. The porous structure decreases the bulk density compared to the classical traditional spray dried powder and increasing the amount of cooled air, improving the dispersibility in the water. So, to conclude this presentation, extrusion process is a continuous process including various unit operations such as mixing, conveying, bleeding, homogenization, melting, cooking, sterilization, expansion, swelling, texturizing, cooling, and drying. Extrusion process is classified into cold and hot extrusion or extrusion cooking, which each of them has specific applications in food production. Extruders could be single or twin screw with co or counter rotation. Extrusion process has a large number of applications on food production, and it could be used in food production for human and animal as well. Some physical and chemical changes and molecular transformation could be happened during extrusion process, including starch gelatinization, fragmentation, protein denaturation, and texturization, and also fiber solubilization is observed. The quality of extruded depends on shear environment in the extruder screw and die, and also on the ingredients and the time temperature history. Vacuum extrusion and extrusion purification are the new trends in the extrusion cooking, with the aim of improving the quality of final product. So by the end of my presentation, I hope that you have enjoyed with extrusion technology and its different applications in the production of large number of different extruded products. Thank you for your attention.
Ma'am, there are few questions by the participants. Number one, what is the difference between rubbery state and glassy state?
What's the difference between
rubbery state and glassy state?
Okay. A glass state is the amorphous state, which is when it dried, for example, any fruits. We can broken it easily. This is a glass state, but rubber states such as the materials which rich in sugar, such as apricot, for example. When it dried, we can get the brittle texture. Is it still rubbery or rubbery texture? We can broken it. It is clear?
Yes, ma'am.
Hello.
Yes, ma'am. Yes, ma'am. Ma'am, the second question is, what about glass transition during extrusion?
What about the glass transition during the extrusion?
Yes, ma'am.
Normally, raw material is in a glass state. So to cooking the raw material, we have to transform glass state to rubber state by adding the water. The water depresses the temperature of a glass transition and transform or change the state from glass state to rubber state to allow the different transformation to happen during the extrusion process, such as gelatinization, protein denaturation, texturization, in order to obtain fluid melt, which is expanded at the dough.
Ma'am, the third question is, how is expansion ratio related with glass transition?
How is?
Expansion ratio is related with glass transition. How is expansion
The
ratio?
glass transition, okay, I understand. The glass transition is a function of temperature and water content. As I mentioned in the effect of water content in the on the quality attributes of the products, I showed you that expansion ratio increased with decreasing the water content. So the higher water content in the products is the lower the expansion ratio. So we have to reduce the moisture content in the final products to transform the state from rubbery to glass state and get high expansion ratio.
Ma'am, the fourth question is, can one create an endless variety of food product by using this technology? Can one
What?
create?
Excuse me.
Anyone can create an endless variety using this technology?
Yes.
Ma'am, can we create endless variety of food products using
Yes.
extrusion technology?
Yeah. Yes, we can. Why not?
Okay. Thank you, ma'am. These were the questions by the participants, ma'am.
Okay, thank you.
Meenu, ma'am?
Yeah, thank you, ma'am. Thank you so much. There is some confusion regarding feedback on feedback form on YouTube. Dr. Deepti, any information about that?
Ma'am,
Yeah.
the webinar, this feedback form is not posted on YouTube. We are trying, but it is going to take another 5 minutes.
Okay.
said by
So
sir.
can you please put it in the YouTube, write
Yes,
it?
Yes,
So because people are asking for that feedback form, so just
yes.
please inform them that
Yeah.
we would be soon sending the
Ma'am,
feedback.
I would like to inform you that due to the security reason, YouTube is not allowing the link to be shared in the chat.
Okay.
So it's better that we should
You can
share the
share
link
it in
in
the WhatsApp group, Meenu.
Yeah,
You can
yeah.
share it in your
No,
WhatsApp group.
yeah, that we have shared, but everybody.
Ma'am, on WhatsApp group, they are not all have not joined the WhatsApp group. There
Yeah.
are many who are without
Yeah.
WhatsApp group.
Yes, this is
So,
the
no
issue.
problem, ma'am. We have taken the screenshot of the participants and we will email them individually. No problem with that. So we will send the feedback form to the participants who are there in the YouTube link.
Okay, so please, this we can, now they have listened to it and we can also write it in the chat box that this is the way we will send the, so please don't worry, everybody, those who have attended the this webinar, they will get the certificates. Yes, any other questions, any queries?
No, ma'am. Everyone is praising the webinar. They are saying it's an informative webinar that will be carried on by Mamta ma'am. Yes, ma'am. Carried forward by
Right.
Mamta. Yes, ma'am.
Yeah, thank you. On behalf of SPM College, I would like to extend our appreciation to Dr. Sabha Munir for delivering the most enlightening lecture on extrusion technology and its application in food product development. Ma'am, it was an honor and a pleasure for us to host you here today. The applications of extrusion in preparing pasta, snacks, flakes, meat analogs, texturized proteins, confectionery, and chocolates were of special interest, as also the other innovations that are possible in the same. Thank you, ma'am, once again. Gratitude to the close to 550 registered participants spanning the globe and many prestigious universities and institutions from India for the overwhelming response we got. Universities represented here today include the Zagazing University, Fayoum University, Damanar University, and the Ain Shams University from Egypt, the University of Lincoln from England, and Univotech from Sri Lanka.
Wow.
Major universities across the Indian subcontinent from Kashmir to down south are here today. Both students as well as their faculties have participated in equal measures. Thanks much for your overwhelming response. Next, I would like to extend our appreciation to the principal of SPM College, Dr. Sadhna Sharma, for her continued support in all academic activities proposed by the Department of Food Technology. Thank you, ma'am. Appreciation to the faculty of the Department of Food Technology, SPM College, the convener of today's webinar, Dr. Meenu Agarwal, and to the co-conveners, Mrs. Mamta Marwa and Dr. Deepti Sharma, continually able to rise up to the challenges and requirements of our current times. Special thanks to Manish and Sarabjit ji and the SPM team for providing tech support for managing all our online programs so efficiently. A round of applause for the student volunteers of the Department of Food Technology. You are our driving force and our strength. Thank you, one and all. Lastly, I would like to add that once the feedback form has been received by you and have been filled up by you, you will be receiving your e-certificates within a week. So thank you once again to all of you for having taken part in this international webinar organized by the Department of Food Technology, Shabha Prasad Mukherjee College. Thank you.
Thanks.
Thanks a lot.
Thanks, Dr. Munir, once again. And I hope we will get a chance to collaborate with you in future also. So I thank everybody.
With a pleasure.
So I thank everybody, all the participants and our team. So thank you, ma'am. Thank you so much.
Thank you. You are welcome, madam.
Namaskar.
خلاص ما قفلوا. قفل فين؟ بس احنا كنا الظاهرين في السهرة البطن. لا كنت عاملة انيميشن حاجات ثانية. المرة الجاية فين بقى؟ مش كانت واضحة قوي على التصوير.
Just one thing, can we have a photograph? Hello? Can we take a photograph? I just forgot about the photograph. All those present, please open your video so that we can just take one snap. I think, but Dr. Sabha has left. I just forgot. Doesn't. Others, please open your videos if possible. Thank you, Manish sir. You were a real help today.
It's pleasure, ma'am.
Have dropped a message to ma'am. She will join in a minute.
Okay, okay. So we will take a final photo.
Dear students, please turn on your video. Don't turn off now, just for 5 minutes. Ritika, Anjali, Raima, Anushka, Urvika, Tanya, Janvi, Aditi. Juhi, Janvi, Aditi, Raima, Anushka. Please turn on your video. Ritika, Anjali, Shivani. Sneha.
Good to see you all girls here.
Anjali, Anushka, Shivani. And ma'am has joined.
Yes, join. Okay.
Where she is joined.
Welcome back, ma'am.
Ma'am, please turn on your
Ma'am,
video.
can
عايز تيجي تعالى اقعد معانا.
yeah, we wanted to take a screenshot. Yeah, thank you, ma'am. Welcome back, and we'll just take a screenshot.
هتشيلي عارفه ما هتشيلي.
Done?
Sneha.
Yes, ma'am.
Is it done?
Yes, ma'am.
Okay. Thank you, Dr. Munir, once again. It was very informative, and I hope we will listen from you again. Thank you, ma'am. Thank you, everybody. Thank you, everybody. Thanks.
Thank you. Good evening.
Thank you. Good evening.
خلاص شيلي خدوا الصورة. شوفي ده حتى وشي باين عامل ازاي. وريها لي على اليوتيوب شكلها ايه. والله يعافيك.